Right, so we are on topic 7, regression. This corresponds to chapter 10, parts 5 to 6 in the current textbook I'm using, which is the Hyman Stat. We covered correlation last topic. Regression allows greater predictive ability than correlation does. Now, most regression analyses are correlational. Regression says nothing about causality. The only thing that can allow you to make causal inference is your research design. But we can use the regression equation, and we'll be seeing that, to predict the score on the dependent variable from a given score on the independent variable. That is, we can get a precise estimate of what one variable will be in light of another. Okay, but our real predictive ability, in the sense that the degree to which we can generalize our findings, that depends on experimental design. Okay, so here's our scientific method. And just to remember, if you take research methods, go and study research, then we'll go into designs like experimental versus correlational and so forth. In this class, we're basically focusing on testing predictions. Okay, so a bit of review. An independent variable is the variable you're studying. In an experimental design, it's the manipulated variable, the one that you are interested in the sense, for example, we talked about the effect of violent video games. If you bring participants into the lab and randomly assign them to play either a violent or a non-violent video game, well, video game violence would be your independent variable, and you're manipulating it by randomly assigning people to do one or the other. After you do that, you would then measure the effect of the video games on your dependent variable, which in this example could be aggression, right, that we've talked to. So the dependent variable is the one you're measuring. The outcome variable, if it's an experimental design, it's presumed to be caused by the independent variable. Now, in regression analyses, we talk loosely about independent variables as the predictor variables, okay, the X variable, and the dependent variable, which is the Y variable, that's the outcome variable or the criterion. But again, this does not allow us to make causal inferences. The regression line is the straight line that best fits points in a scatter plot, and we've seen that already, right? You guys have made scatter plots and you've added a regression line, and you'll notice that here I've left in what SPSS automatically includes, which is the regression equation, okay? And we'll be looking at that, exactly what that is. For now, you can see it says y equals, so this is y, so this is your y-axis right here, equals 21, which is your y-intercept, plus 1.04x. So on this graph, we actually can't see the y-intercept because we don't see 0. So the y-intercept is just the value of y where x equals 0. So it's out here somewhere, right? It's way out here, right? And this is the slope right here, okay? And you might be familiar with that from math classes, and we're going to do a bit more review here, okay? So the formula for the line in math is usually written y equals mx plus b, where m is the slope and b is the y-intercept. Again, the y-intercept is the value of y with x equal to 0. The slope is the change in y per 1 unit change in x. Okay, so if you go up 1 in x, what happens to y? That's how much y changes. Most statistics texts use the regression equation in this format. Y prime, that's just like a little, y prime is what we say, and this is it. This is the little asterisk. It's not precisely 1, but it's like 1. You can use an asterisk. Equal a for the y-intercept plus b sub y x, or just bx, and b sub y is the slope, okay? Y prime, sometimes you'll see y hat. That's just the predicted y score. That's the y score on the regression line for the value of x that you plug in here. Okay, so here's a regression line. We can see it's a negative relationship because as anxiety The first time goes up is anxiety goes up, performance goes down, right? People who are anxious tend to perform worse, right? Okay, that's the x-axis, anxiety, and the y-axis is performance, right? This is where x equals 0, okay? So there is the y-intercept, right? Looks like it's about 80 something, okay? So y prime equals a plus b sub yx. So a line or a point on a line, right? The y-intercept plus the slope, location of the scores on x, okay? We use this formula two ways. First is just the regression line. It is descriptive. It describes what the regression line looks like. And you get that with mathematical formulas, which we'll see, right? It's line of best fit. It can also be used to predict scores. And we use it quite a bit. And we'll be doing that a lot in this class. So let's walk through an example. We're going to talk about perfectionism and state happiness, right? Perfectionism is just insisting that everything you do be as perfect as possible, right? State happiness means happiness over the last 2 weeks. So when we measure things in psychology, we talk about trait and state constructs. The trait is just your whole life, okay, in general. State is your recent happiness. So how happy you've been recently. If you spoke Spanish, I suppose felicidad would be a trait, and contento, that would be state, right? Okay, so correlation. Correlation basically is answering the question of what the relationship between X and Y is. Whereas regression can answer the question of, if we know X, how well can we predict Y, right? It's basically the same thing. As I said, regression 2 is a correlational analysis unless you're using regression to test hypotheses in an experimental design. So let's go back to perfectionism and happiness. So here we have the scatter plot with perfectionism on the x-axis and happiness on the y-axis, and we see clearly this is a negative relationship. So for perfectionism, score of 60, what will we expect for happiness? All right, we can go straight up from that X value of 60, and we can see it looks like it's about 92 or so, right? That would be the value of Y at X equals 60. What about the value of Y at perfectionism equal 120? Okay, our best guess here would be a little below 70, maybe 69 or 70, right? So the question here is, how accurate is this? How close are scores to the line? Okay, here we see there's actually quite a bit of spread in these values. It looks like a negative relationship. But for example, perfectionism of 80, so right here. Okay, yeah, there are scores that are pretty close to the line here, but there's also scores all the way up and down, so it's not too accurate necessarily. However, it's a pretty steep slope, so it's better than something like this when you have very, very small or weak correlation, right? You can't tell a lot about Y based on X. You can see that depression, people's degree of depression doesn't say a lot about their IQ, right? For example, for a depression score of 20 or about 20, the depression score of 40, for both cases, for 20, we get about 115, and for 40, we get about 118. Very little difference, probably not meaningful at all, right? So which is more accurate? Stronger correlations lead to better guesses or predictions, right? So let's think about that. A correlation means there's a systematic relationship between our variables, okay? So the higher the correlation, the more systematic the relationship and the better the prediction, right? So let's look at some more details here. Actually, I'm going to pause this right here, and we're going to make video 2. 1 second.